Hey there! In this video we will learn something new. If this is your first time learning reinforcement learning in PyBullet, we will go through every concept step by step and slowly. And if you already know some of the knowledge in later of this video, you can either sit back and relax or watch other complex reinforcement learning course. Now let's get started. Here I'm using Visual Studio Code. If you have other coding platforms like PyCharm, that's basically the same thing. Now go ahead and create a file name, and if you want to be organized, you are definitely feel free to create a folder. To run PyBullet, we have to install its library. To do that, we simply navigate to our terminal and type pip install PyBullet. It would probably around a minute or so to download it. In my case, I have already installed the library, and after you have installed PyBullet, we are free to start coding. To import the library we just installed, we type import PyBullet. What's next? Well, our first step is definitely to open a 3D world simulation. And how can we do that? To do that, we use the method called PyBullet.connect, along with PyBullet.gui. What is GUI and why do we need this? We need it because GUI lets us run our simulations while the window is open so we can watch the robot. Or you can write it as direct, which means it runs the simulation without a graphical user interface. It runs code headlessly, with no rendering overhead, which makes it ideal for fast training loops in machine learning and reinforcement learning. In this case, we will use GUI, so we can watch the 3D simulation. Now we have opened the simulation, but you might sense something is missing. Can you guess it? Well, that's gravity. To set gravity and simulate real-world physics, we write PyBullet.setGravity. Inside this parenthesis, we need to pass three parameters, that is x, y, and z. We all know that gravity pulls objects downwards and it is 9.81 meters square. In axis, I'm pretty sure you know z is up and down, so for the parameters we want to keep x and y to 0, while setting z to negative 9.81. And there we go. We have the gravity in our simulation. After we have the gravity, we want to make the application or window stays. To do that, we can use time. Go ahead and import time. Now write time.sleep under the gravity code that we have previously written. You can set the time to 5 seconds, 100 seconds, or even more. In this case, I'll set it to 10 seconds. After you have time, we want the simulation window to close after 10 seconds. How can we do that? To achieve that, we use PyBullet.disconnect. This method allows the system to automatically close the application after a specific time, which is the time that we set. And there we go. We have our simulation ready to run. Simple, right? After the specific time, the window will automatically close. In the terminal, you will see that it outputs thread terminated. If you ever feel typing PyBullet is tedious, then you use the word as at the line where you imported your PyBullet library. Now you just use p every time when you want to use a method or function from PyBullet. This makes our code more clean and easier to read. Next, PyBullet doesn't automatically move time forward. Time.sleep freezes the window for 10 seconds. To make physics actually happen, like things falling or moving, we need to tell PyBullet to tick its clock forward step by step. Now you might ask, what is 1? Divide by 240. Well, PyBullet's internal clock updates 240 times per second by default. By putting time.sleep open parenthesis 1 dot slash 240 dot close parenthesis inside the loop, we match our real-world time to the simulation's time. Step simulation means to tell the physics engine to calculate the next fraction of a second. This is mainly for physics. Now go ahead and run the code again. If you run your current code, a black or empty window will pop up. To make this look like a real simulation environment, we need to add two essential elements, which is a floor or ground plane. Without this, anything you spawn will fall forever into a dark abyss. Now let's get into the fun part. How do we import an object into our 3D simulation? Well, we use import PyBullet_data. This gives us access to free 3D models, like floors and robots, from PyBullet. Now, after we have imported the new library, how do we find the assets? That's a good question. We need to tell PyBullet where to find standard assets, like the ground. To do that, we use p.set, additional search path, PyBullet_data.getDataPath. I know this line looks scary at first, but after you write it many times, your brain will begin to slowly memorizing it. After that, we have found the asset and we want to load a visual floor into our world. What do we do for that? Well, we use p.loadURDF. In the parentheses, you pass in the model that you want to import into the 3D world. In this case, we want a platform for our later objects to touch the floor, so we type in plane.urdf. This is a pre-made file provided by PyBullet data. And there you go. Try to run the Python code again and you will see the platform appearing in your simulation. That's simple, right? Now let's import our first object. Since this is our first time learning, we will try to import a soccer ball. How do we do that? That's really simple. Just use p.loadURDF again and pass in the soccer ball model name. Now, when you run the simulation, you will see a football spawning at x equals 0, y equals 0, z equals 0. You are able to use your left mouse button to drag the object around. Try to hold your left mouse button on the object and play it around. If you want to set the object's spawning coordinate, you can do this by using base position. Now here you need to pass in a x, y, z coordinate list. For this practice, we would like to see the football spawning in the air. Let's set it to z as 2.5. Run the program again. You can see the football appears at a different position. And we have finished part 1. In part 2, we will explore further by getting the object's positions or coordinates and learn slightly advanced features. See you there.